Alrighty, so we're going to be taking a look at rational expressions and functions part 2 here. We're going to get into actually doing operations and being able to look for those common factors and be able to reduce. So rational just means ratio. So we're looking to see how we can um, simplify and work with things that are ratios. So to do a quick warm up here, we're going to do some monomial ones first. So things that we've talked about before. So basically we're trying to reduce fractions. We're looking for things that are in common. So I'm going to rewrite this a little bit bigger here so we have a little bit more room to maneuver. What you want to do is look for things that are in common top to bottom, common factors that we can divide out. So I feel like I kind of sort and organize. So I look at numerical values, so coefficients, and see if there's anything I can do to reduce them. So both 40 and 2 are even, so I can divide them both by 2. So they're both divisible by 2. So like dividing out a common factor of 2, so 40 divided by 2 would be 20. And then 2 divided by 2 is just 1. So that reduces down to 20 over 1, or just 20. With everything else, I might wait and see if I still need that ratio, if everything ends up to be simplifying as well. So one variable at a time. So let's take a look at the m's. I have m to the third in the numerator and m to the ninth in the denominator. So where do you have more m's? Well, on the bottom. And how many more? Remember our rule, we subtract, so there's 6 more on the bottom. So that would be an m to the 6 in the denominator. So remember, thinking about what's happening, you're taking 3 m's and you're dividing them out. So we're dividing by an m to the third, really, top and bottom, and that's leaving you with that m to the 6th in the denominator. So kind of sorting and organizing, one variable at a time here. Last one is the p's. P squared over p to the first. Remember, if there's no number written there, it's a 1. Where do you have more? Well, on the top. And how many more? 1. Remember, we do our rule, we subtract. 2 minus 1 would be p to the first. So we get this all the way simplified down to 20p over 1 times m to the 6. Now, you don't really need to have the 1, so if that's bothering you, you can just go ahead and write it out like this. So that's the basic idea of simplifying a rational function or a ratio. We're looking for the common factors and seeing what we can divide out. Now, when your common factors happen to be binomial terms, right, things in parentheses, we just have to be careful that we actually know what those GCFs are and we divide them out. So some people say canceling. Another way to think of that is it's dividing to 1. So we're dividing out those common factors. So first one's already factored for us. We're looking for common factors. They just happen to be binomials this time. We're going to look for what's the same. So I see a common binomial factor of x plus 3 in both the numerator and the denominator. So if I divide both of those out by x plus 3, that's going to leave me with a factor of 1, because the same thing divided by itself is always going to be equal to 1. It's no different than saying 7 divided by 7. I can divide each of those factors by itself, and same thing here. I can divide each of those factors by itself. So I can reduce that fraction by dividing out that common factor, and what does that leave me with? Well, all I have left in the numerator is x minus 2, and the denominator x plus 2. Now some people might think, okay, can I do anything else? Well, no, you can't, because those binomials are not exactly the same. They would have different values if you plugged in a number for x. So if you have a binomial, the identical thing is what we need to divide out, not anything that has that opposite sign in the middle. Those would not have the same value. So just make sure you're looking for that exact same factor top to bottom. So that's as far as we can go. We can't simplify anymore. So resist the urge to kind of overdo things. Take a look at the next one. This one looks visually different to me. No parentheses, right? So we need to factor it first. There's no way to divide out a common factor unless it's already factored. So we need to factor first, top and bottom. So we're going to be practicing some of that factoring from chapter 6 here, top and bottom. So I'm going to have you go ahead and pause the video. We're going to factor the numerator and the denominator. So see what you can get for those binomial factors. So pause, get your factors, and then go ahead and check back in here. All right, so remember, y squared comes from y times y. And then we want numbers that multiply to -3 and add to 2. So multiply to -3, 3 and 1 are our only options. If we want them to add to +2, that means the 3 would have to be positive and the 1 would have to be negative. Remember, you can check your outsides plus your insides. 3y -1y, that adds to 2y. You can double check and make sure that you did the right arithmetic there. All right, for the denominator, we're going to do the same thing. All right, so we have a y squared, so y times y. We want numbers that multiply to 2 and add to 3. Multiply to 2 is 2 and 1. That's your only options. And since it's a positive 2, that means the signs are the same. We want it to add to a negative 3, so they both have to be minus. All right, so now, are there any common factors? Sometimes you factor like this, and there's nothing you can divide out. But in this case, I notice a common factor of this y minus 1. There's one in the top and one in the bottom. So when I divide them out, it divides to 1. Same thing divided by itself. That's a factor of 1. So all you have left then is y plus 3 over y minus 2. And remember, I can't take part of a binomial. That has to be identical to divide it out. So y plus 3 is a different binomial than y minus 2. That's as far as I can go. So always, always, always factor first, then reduce. All right, let's take a look at some more. We're going to take a look at some more types of factoring to help us be able to see what we can take out. So we're going to look for GCFs and then divide out those common factors. All right, so let's take a look at top and bottom here and see if we can factor each of these. They are not factored already because there's no parentheses, right? So I know I need to factor. So let's take a look at the numerator, x squared minus 25. That's called a difference of squares. Go ahead and pause the video, see if you can factor just the top. So see if you remember how to factor numbers where there's that no middle term. So they multiply to negative 25, add to 0. So x times x gets us that x squared. 25, negative. That means positive 5 and negative 5. So we have a plus 5 and a minus 5, whichever order you want to write them. When you do outsides plus insides, they add to 0. That's why that middle term isn't there. That's called difference of squares. On the bottom, we have a little bit different strategy. So let's make sure that we know what we're doing. The first thing we look for when we're factoring is a GCF. So I'm going to see if there's a common factor here. It only has 2 terms and nothing is squared. What could you pull out of both a 5 and a 25? Well, 5. What's left inside then? So 5 times what would give you 5x? Well, that would be an x. 5 times what would give you 25? That would be a 5. Since it's a plus, that would be a plus. So sometimes what we're doing when we're factoring is just doing a GCF. It's not even 2 binomials. So be careful when you're looking for that. Make sure you check for GCFs if it doesn't look like it's going to factor into 2 binomials. All right, now, is there anything that's in common that you see top to bottom? Well, I'm seeing a common factor of x plus 5 in the top and the bottom. So I can divide that common factor out, which means it's going to divide to 1. What do you have left? Well, in the numerator, we have x minus 5, and then in the denominator, over 5. Now, some people will want to try to reduce those 5s and say, oh, look, there's a 5 in the top and the bottom. We can't because x minus 5 is a binomial. It has the value with the x, so we can't just take part of a binomial. It's all or nothing. It's either the whole thing or it's not at all. It wouldn't have the same value because if this is going to be reduced down to just an x, doesn't make sense from what we started with. We have to only take out those common binomial factors. All right, so now we're going to up the game here a little bit. The denominator looks super similar to the last one. So that last one, we did a GCF down here, and I think that's going to be something that we want to do in the bottom here. What could you pull out of a 2 and a 4? Well, that would be a 2, and then we'd have w plus 2 left on the inside. So the numerator is not so bad on this, or the denominator. The numerator is a sum of cubes. Now, I'm not sure you remember. If you can look back into your chapter 6 notes, I want you to flip back in your chapter 6 and find the sum of cubes formula. So go ahead and pause and see if you can look back and find that. We have a formula that's going to work great for this. So go ahead and pause the video and see if you can find that. So the sum of cubes, so a cubed plus b cubed, that's the formula you're looking for. It's a binomial, a plus b, and a trinomial, a squared minus ab plus b squared. And if you remember, we talked about what are each of the things being cubed. Those are like our a and our b. So in this case, our a is the w. That's what's being cubed. And the b, what cube gives you 8? So what times itself 3 times? So 2 times 2 times 2. So our b must be 2. So we're going to replace the a with w and the b with 2. All right, so a is w, b is 2, and then we have the a squared, so w squared, minus a times b, so 2 times w. I like to put the number first, it's just easier for me, and then b squared, so 2 squared. 2 squared is 4. So I can use that sum of cubes formula to help. So now I have it factored. I actually have that product. Now I can divide things out. Looks like I have a common binomial factor of this w plus 2, so that divides out to a factor of 1. So I'm left with w squared minus 2w plus 4 all over, looks like, a 2. So when I'm simplifying and working with these values, I'm always trying to factor first and then reduce. So break it down into a product of factors. All right, let's try a couple more here. This is kind of some of the special case things that we need to talk about. So we'll do a few more and then I think we should be in good shape. Let's take a look at the top one, x squared plus 100. Now, when I look at that, I'm trying to see if there's any way I can factor it. So I'm going to check for a GCF. There's nothing I can pull out of the top. It's not a difference of squares because it's a sum. There are no numbers that multiply to positive 100 that would add to 0 because to get a positive, they either both have to be plus or they both have to be minus. And I can't take only part of this. I would have to reduce here as well. So that doesn't really help me. There's nothing I can do to factor this, so that means it can't be reduced. This one is already simplified. So when I'm thinking about, okay, how can I move forward or can't I move forward? You can't on this one. This is as simple as this one's going to get. The only thing you could do is just write both of them over 200 if you wanted to, right? We could simplify it that way, but I'm not sure that that's a wonderful help because I'm still going to have fractions for both of them. So you really can't do anything to reduce this fraction because there aren't any common factors. All right, let's talk about this situation. Sure looks like that we should be able to do something, right? These are called opposites, and we're going to start looking for opposites because that is something else that we can actually reduce. Things that are opposite would be like, what if I had 6 divided by negative 6, or negative 6 divided by positive 6? I can still reduce those, even though they're not exactly the same number. When you reduce it, what do you end up with for each of these? Well, they're each -1. This is the same situation, but in the variable form. R minus 1 and 1 minus R are opposites because if I take -1 and multiply it by 1 minus R, let's see what happens. That would give me a negative R minus minus would be a +1. Or if I just rewrote it in the other order, that's your 1 minus R. So they are opposites. So when we take a look at these, if you see something like that where you have the exact same thing, just opposite, we can reduce those and they reduce to a factor of -1. So we want to look for opposites. Those can reduce as well. So just like we can for numbers. So we want to kind of add that to our repertoire here, to our arsenal, so we'll be able to see that. All right, so let's take a look and see if that can help us on this next one. Nothing we can do on the top, so p minus 2. Let's see if we can factor that denominator. So that's a difference of squares, right? It's a minus, so we know we can factor it. It's a 4, so 2 times 2. P squared, so minus p and then plus p. So remember, difference of squares, we have two things that are perfect squares with a minus in between. Now, it may not look like we can do anything, but take a look at these two terms. They are opposites, just like the last one. P minus 2 and 2 minus p. If you multiply one of them by -1, you get the other one. So actually, I can reduce these out, but they leave a factor of -1 left instead of +1, just like our 6 and -6 would. So we'd have -1 over 2 plus p. Or you could say 1 over 2 plus p and just put the minus sign right out front. That would be the same thing. So look for opposites. That will also be part of our conversation. If they're the exact opposite, I can still divide those out. Okay, so day 2, make sure you always factor first. So if we're trying to reduce, factor first. So break things down into a product of its factors and look to see what you can divide out. When you're factoring, don't forget to look for GCFs, and then you're going to factor things into binomials, and don't forget about your cube formulas. You have those to be able to do as well. And then we're also going to check for opposites. So if we have opposites, we can also divide those out. So that's kind of our big picture idea for simplifying with these rational expressions.